Yo, let's talk about contracts. We live in a world of agreements. When I pull up to a stop sign, I expect that other people are going to stop. When I put my recycling out, I expect that the city is going to come and pick it up. When I see a sign on the street, I expect that it means what it says. All of these are contracts that are formed with us or that we form with other people. They're super important because they tell us what to expect. I expect light switches to turn the light on when I flick it in the appropriate direction. Each of these plugs, just by its appearance, warrants that it fulfills the contract of moving electricity from the wall to somewhere else. Even these light bulbs that may not look the same have a base that implies a contract with a socket. We expect that when we put them in that socket, the light will turn on. In software, we have contracts too. We expect that when we call a function with the appropriate set of parameters, we're going to get an appropriate return value. One of the things that can be very confusing is interfaces. Interfaces seem to imply that there's an actual contract with the code, but in actual fact, there's no guarantees. You might grab an instance of an IO writer in Go, or an object that implements the iterable protocol in Python, but neither of these objects is guaranteed to actually perform the way you think they do. Oh sure, the iterable will return something, it will allow you to iterate, but you have no idea whether that contract is actually the contract that you think you've entered into. And this is because interfaces fundamentally only enforce signatures. They don't actually enforce the underlying behavior of the object. In some cases, this is a good thing. For example, if I want to write a byte counter that I want to insert into a chain of IO writers in Go, I can easily do this. I implement my write method, I count my bytes, and I output that to somewhere else before passing the bytes on to the next writer in the chain. And this makes total sense. But barring a few very specific languages that are built for this purpose, it leaves us with no way to verify that the contract that we're expecting from a given method is actually being upheld by the code that implements it. So when you're writing code for others to use, make sure to document carefully any departures from idiomatic uses that others might be expecting from your functions. When someone picks up your class, your function, your method, it should be simple for them to understand, and they should immediately understand whether it fully fulfills the contract that they're expecting, or whether there are some deviations, for example in the case of the byte counter, that totally make sense but that they absolutely need to know about. When a part of your system depends on somebody else's code, the burden is on you to check to make sure that the contract that you're expecting is actually being upheld by that code. Take a look at the implementation of the methods and make sure that your list that you're passing isn't too long, or that the string isn't too large, or that your pointer isn't pointing to something that that method isn't expecting. Otherwise, you're going to get some very strange results, and they're probably going to happen in production. Finally, if you only take one thing away from this video, remember that just because it walks like a duck and talks like a duck does not mean that it isn't a highway. That about wraps it up. I hope you enjoyed the video, and if you did, consider subscribing for more content like this. Hit the bell icon to be notified when I upload my next video. If you're already subscribed, thank you so much. It really means a lot to me. Hit the thumbs up below to let me know that you liked this video, and I'll catch you in the next one.